Hello everyone, welcome to our YouTube channel, and as you can see that today's session is going to be about the squares and cubes, right? And in the previous lecture we have discussed about the various methods of simplification, especially multiplication tricks, right, and a few of the division tricks, right? And in today's session we'll learn that how to find the squares, right, and how to find the square roots. Then we'll work on few tricks based upon the cubes and cube roots, right? So again, as I told you in the first lecture, that we need to be well versed with tables. First thing, the tables we should be aware about the tables from 1 to 20. Second is squares from 1 to 40 and cubes from 1 to 20, right? And in today's session, you will be able to watch this session. You will be able to learn the things through this session only if you're clear with the squares till 40 or the cubes till 20, right? If you're not, right, you can wait and you can learn those things and then you start following the things, right? Because normally in exams, especially in the banking exams, right, or in the other computer exams, normally we find one or two questions based upon the squares and cubes, right? So we'll try to fix up those one or two marks in our computer exams for ourselves, right? So let's start with the things. Yes, I hope that you are ready with the copy and pen. Okay, right. First of all, that I assume that I will be using the squares from 1 to 40, right? 1 to 40 squares, as I told you that you need to learn at your own. This is your homework. This is expected out of you, right? Then afterwards, let's start with the things. Normally, from 1 to 25, I think the squares we know the squares, right? Then beyond this, from 1 to 25, we are aware, right? So I'm going to discuss few tricks that how to find the squares beyond that, right? Beyond 25. But till 40, again I'm telling you, till 40 you should learn the squares, right? But the method that I'm going to discuss with you, that works from 26 onwards, right? See, what we do from 26 to 75, if I have to find the square, right, then we use the base method. We can use the base method, right? What we take between 26 and 75, there is one number, that is 50, right? So we take base 50 for to calculate the squares between 26 to 75, right? Look here how it works, right? I can just share some examples so that you will be able to identify the thing that how you can solve these questions, right? Let's start with the things. First of all, let's assume that we want to find the square of 54. We have to find the square of 54. Now, we compare 54 with the base. Base is 50, right? As compared to 50, in 54, we can say that there is plus 4. 54 is 4 more than 50, right? So it is plus 4, right? Now, square of 50 is what? 50 square is 2500. So what we do, we compare this with 50. 54 is compared with 50. It is plus 4, and this plus 4 is added into 25. This 25, right? 4. So it becomes 29, and then this 4 square is 16. We write it 16 over here, right? Clear? So what we do, if we have to find the square of 54, we compare it with the 50, right? And then as compared to 50, there's plus 4. 4 is more than 50, right? So this 4 is operated upon 25, right? 25 is half of 50. You can learn it that way as well, right? So 25 plus 4 is 29, and then 4 square is 16. This is the square of 54. Again, I take one more example. If I have to find the square of 56, right, what I do, I compare it with the 50. So as compared to 50, it is plus 6. It's 6 more than 50. So 25 plus 6 is 31, right? What I need to do is I need to compare with 50 but operate on 25. So it is plus 6. So 25 plus 6 is 31, right? And square of 6 is going to be 36, right? So this is the square of 56. Clear? What we do, I take one more example. If I have to find the square of say 57 square I need to find. What I do, it is I compare with the 50. As compared to 50, it is plus 7, right? So 25 plus 7, it comes up to be 32, and 7 square is 49. It's very easy, right? Any number that we have, right, we can just simply write it here. Say we have some number, say 58, right? So what we do, it is plus 8 as compared to 50, it is plus 8. So 25 plus 8 is 33, and 8 square is 64. This is the answer we get, right? Similarly, if there is some number which is less than that, 46 square we want to find, so it is minus 4. It is minus 4 as compared to 50. So 25 minus 4 is 21, and 4 square is 16. So we get the answer directly in a 2-second time. We can find the answer, right? If I have to find the square of, say, 43, so it is minus 7. It is 7 less than 50. So 25 minus 7 is 18, and 7 square is 49. Directly we can write out the answer, right? So this is how we can find. We can find the answer to any number. Say we have to find the square of 52. So it is plus 2. 25 plus 2 is 27, and 2 square is what we do? Not 4. We write 04. 04, because by squaring we are going to write the last two digits. 2704. Right? Similarly, if I have to find the square of 47, so it is minus 3. So 47 minus 3 is 3 less than. So 50 minus 25 minus 3 is 22, and 3 square is 09. So answer will come out to be 2209. Right? So this is how we can operate the squares till 25 to 75, 26 to 75, right? But if we go towards the bigger numbers, right, bigger values, right, like if I have to find the square of 62, what I do? 62 square I have to find it. So we compare it with the 50. As compared to 50, it is plus 12. As compared to 50, it is plus 12, right? Now we add 12 into 25. 25 and 12 is 37. And 12 square is what? It is 144. So this one need to be added into this. So my answer becomes 3844. My answer becomes 3844, right? If I have to find the square of, say, 66, square of 66, what I do? It is plus 16. It is plus 16. As compared to 50, it is plus 16. So what we do? We add 16 into 25, which comes out to be 41, and 16 square is 256, right? And this 2 has to be added to this. It is 4356, right? So we need to know that why we are adding, because in the last lecture itself, right, we have discussed that how this multiplication or the square accounts for only last two digits. If we get a 100 place digit, this digit need to be added into the 100 place digit of the next value, right? It's 41, and this 1 and 2 is 3, 4, 3, 5, 6, right? If I have to find out the square of, say, 37, so it is minus 13. As compared to 50, it is minus 13. So 25 minus 13 is 12, and 13 square is 169. 169. So 69 will remain. This 1 will go into this 1369. Right? So we can find the answer directly. But till 40, as I'm telling you again, till 40 we need to learn the squares directly. If we have a bigger number like 71 square, so it is plus 21. So 25 plus 21, because we compared it with 50 and apply it on 25. 25 plus 21 is 46, and 21 is square is 441, right? Then this 4 is added into this, we get 5041 as the answer. So we can find the answer in a fraction of second. In 2 to 3 seconds we can find the answer. Clear? Right? So this is how we can find the squares till, if we have to find the squares till say 75, right? If we go beyond 75, if we have to go in the range of 75 to, say, 125, then base 50 will not work. We need to change the base, and we change the base to 100, right? And how do we? There's a little bit difference between how the base is operated. Say if I have to find the square of 104, right? What I do? As compared to 100, what is there? It is plus 4. It is plus 4. So it is 108. We simply add this 4 into the original number. Original number is 104. As compared to 100, this plus 4. 104 plus 4 is 108. And this 4 square is 16. Right? Directly we write the square of 4. Right? If I have to find the square of 106, 106 square is, as compared to 100, it is plus 6. We add 6, 112, and 6 square is 36. Right? If we have 107 square, plus 7 is there, 114, and 7 square is 49. Pretty easy, very easy concept, right? If we have a number of say 92 square, right? So it is minus 8 as compared to 100, it is 8 less than, so it is minus 8. So 92 minus 8, that comes out to be 84, and 8 square is 64. So my answer is 8464. Right? If I have to find the square of a higher number, bigger number, say I take up the value to be 113, right? 113 square. So what happens? As compared to 100, it is plus 13. So it is 126. And now 13 square is 169. So what we do? We add this 1 to 6. So my answer becomes 12769. Right? Similarly, if I have to find the square of 122 square, so as compared to 100, it is plus 22. We add up this one, 144, 22 square is 484. So this 4 will add into this. So my answer will becomes 11884. Right? Directly we get the answer. So things are very easy. The only thing is that we need to follow a system. If you follow the things systematically, we can easily find the answer. Clear? Now, if I give you some question, like we have some question, say I have to find the square of 103 square. So it is plus 3, 106, and 3 square is, we write it 09. We write it 09. Right? Similarly, if I am to find the square of 98, 98 square is as compared to 100, it is minus 2. 98 minus 2 is 96, and 2 square is 04. So I get the answer to be 9604. Clear? So it's very easy. The only thing is that we need to follow the concept spiritually, right? If we focus on the concept, we can find the question very easily, right? We don't need to. We can do it orally, right? We don't need to work. We don't need to write, right? We can simply use the brain, and directly we can reach out to the answer, right? So say I have to find the square of 114, right? So 114 is 14 more than, it is 14 plus 14 is 128, and 14 square is 196. So 128 and 196, so 12996. Directly we just need to visualize the picture, right? And we can directly reach out to the real answer, actual answer. Fine, right? So these are the squares till 125 we need to find out, and if we have to find the squares beyond that, beyond 125, then how we can approach? Look here. Say we have squares from we want to find the square of say 207, right? So what we do, we follow the same approach. There's a little bit of twist, little bit of difference, right? So we'll apply that one here, right? What we do, the base taken for 207 square, base taken will be 200, right? So it will be, as compared to 200, it is plus 7. We add up this one, it is 214. It is 214, right? Then, because earlier we were using the base to be 100, and now what we are doing, we are going to use the base to be say 200. So it is twice of 100, is 2 times, right? So what we do, when we add a 207 plus 7 is 214, then we double this, because it is doubled. 200 is double of 100, so it is doubled. So it becomes 428, and then this 7 square is 49. My answer is 42849. Directly I get the answer, right? Similarly, if I get across a number, say 312 square, so it is what it is, plus 12. First step is same, 324. Now because base is what? Base is 300. This time around I'm using, we were using base 100. Now the base is 300, so it is 3 times. So if it is 3 times, I have to multiply this by 3. So it will become 972, and then square of 12, it is 144. This 1 will get into this, right? So my answer becomes 97344. Right? The question is very easy, concept is very easy. Only thing is that we don't need to skip anything, right? We need to follow a system properly. We need to follow a proper system. We will find the answer easily. Clear? Right? Let's take on some more examples. Say if I have to find the square of 494 square. So it is minus x. It will come out to be 488, and now I need to multiply this by which number? By 5, because here I'm taking the base to be 500. So 5 times of 100, right? It's 500. So what we do? We multiply this 488 by 5. So if we multiply it by 5, what is 448? 488 is 500 minus 12. 500 into 5 is 2500 minus 5 into 12 is 60. 2500 minus 60 is 2440, right? Directly I can write the answer. 2440. It is 500 minus 12. 500 into 5 is 2500 and 12 into 5 is 60. So out of 2500, 60 has to be subtracted. So it is 2440, right? And then square of 6. Square of 6 is 36. So my answer comes out to be 244036. Directly I can find the answer. Directly I find the square. Clear? Done? Next, if I have to find the square of a vegan number, say if it is given that you find the square of 987, right? So what I do, I take the base to be 1000 base. So as compared to 1000, it is 13 less than, it's minus 13. So it will come out to be 974, right? Now base is 1000, so it need to be multiplied by 10. So 9740 and 13 square is 169. So this 1 has to be added to this. 974169, right? You can check it out, check out this answer through calculator as well. You'll find the correct value, right? So there's no issue with the thing. Only thing is that the things are easy. The only thing is we need to follow a system, right? If you follow it systematically, the things will become very easy, right? Before that, there was few of the examples that I would like you to solve, right? I'm just writing down the few of the examples, right? I hope that the concept of square is clear, right? How to find the squares, right? I just want to share some examples with you people, right? And you just try to solve these numbers, right? Find the square of say 4463 square, right? Then you find the square of 37 we had done, right? You find the square of 39, then square of 68, and then find the square of 89, find the square of 86, find the square of 82, right? Find the square of 99, find the square of 108, find the square of 117, right? Right, just for the practice sake, right? So what we do, 44 is, as compared to 50, it is 6 less. 6 less, 25 minus 6 is 90, and 6 square is 36. 63 is plus 13 as compared to 50. 25 plus 13 is 38, and 30 square is 169. 3800, 38169. So answer will come at 3969, right? Then 39, so 11 less than 25 is 14, and 11 square is 121. So this will be added up into this. 1521 is the answer. 68 is plus 18, 25 plus 18 is 43, 18 square is 324. So answer will come out to be 4624, right? 89 square is minus 11, minus 11 is further 11 is subtracted out of it. 78, 11 square is 121. So this will be 7921, right? Next we go to 86. 86 is minus 14. 86 minus 14 is 72, and 14 square is 196. So this will work out to be 7396. 82 is minus 18, and 82 minus 18 is 64 and 18 square is 324. So it will come out as 6724. Right? 99 is minus 1 and minus 1, 99 minus 1 is 98 and 1 square is 01. 108 plus 8 is 116 and 8 square is 64. 117 plus 17 is 134. 17 square is 289. Answer will come out to be 13689. Right? So questions are very easy. Easily you can find out the squares. Hardly any issue, hardly any problem. The only thing is that follow it religiously. Right? One more concept with regard to finding the squares, right, that I would like to discuss with you is that squares of numbers ending with 5, right? Squares of those numbers which end with 5. Say, if I have to find the square of 35, right? So here what it follows. It is very simple. What we need to, 5 square is 25. In the end, we get 25 only. This 3, in 3 we add 1. That's 3 plus 1 is 4. So 4 into 3 is 12. And 5 square is 25. That is always there, right? Just in the tens place digit is add 1. It becomes 4. 4 into 3, that is 12, 25. In case of 45 square, right, what we do? This is 4. We add 1 into this, that's 5. 5 into 4 is 20 and 5 square is 25. Right? If I have to find the square of 55, so 5, this at tens place it is 5. 5 plus 1 is 6. 6 5s are 30 and it is 25. It is 25. 30, 25, right? If I have to find the 65 square, 6 and 1, 7. 7 6 are 42, 25, right? Then 85 square, if we want to find 8 and 1 9. 8 9s are 72 and 25, right? Similarly, if we get a number, say 105 square, right? If we get a number 105 square. So here, instead of having one digit on the tens place, we have two digit at the tens place and the 100 place. So we take it to be the one number, right? It's 10. We add 1 into this, 10 plus 1 is 11. 11 into 10 comes out to be 110 and 5 square is 25, right? If we take a one number, this say it is 115 is there, 115 square is there. So what we do, 11 into 12. 12 into 11 is 132, 5 square is 25. Right? If I have to find the square of 195 square, so 19 into 20. 19 into 20 is 380 or 5 square is 25. If I have to find the square of 305, so 30 and 31. 31 into 3 is 930 and 5 square is 25. So we can find the direct answer using the squares of using this concept for the numbers which have 5 as their unit digit, right? So directly we can find the answer, very easy, right? But other than this, if the numbers are not ending with 5, we have already discussed one concept, that the base concept, base method, and we can find the squares through that, right? And then along with this, that one approach, one method that I would like to discuss, one more method that I would like to discuss with you is that is duplex method, right? You might be feeling that if we do one method or two method or three methods, right? So things will confuse you, right? So what I would like to add into this is, right, you need to learn 2-3 methods because they work on the different digits, right? They work, it depends upon the digits that which method is going to make the things easier, right? So all the methods are equal, right? If you want to follow one particular approach, you can do that, no problem with that, okay? And generally, if we talk about the squares up to 100 is sufficient one, right? It's very rare that you will be asked, you will be given a number more than 100 to find a square, right? Next we go to duplex method. Duplex method directly uses one property of the square, that's a plus b whole square. Formula is used over here. So how we use it? Say I have to find the square of say 72 2. 72 square I need to find out. So how do we approach? In duplex method, we directly write down the answer by writing the number in this format, right? It is 2 into 2 is, sorry, 2 square is 4. Here it is 2. 2 square is, it is 72 square. 2 square is 4, right? We are left with nothing. Then we multiply all these three digits. 2 2s are 4, 4 7s are 28. We get 28, 2 is carried. Then 7 square is 49, 49 plus 2 is 51. My answer is 5184. Got it? Say I have to find the square of 63. What I do? 3 square is 9. I write here 3 square is 9. Then in the next step, in the second step, I multiply all three. 2 3s are 6 and 6 is 2 into 3 6. 6 into 6 is 36. 3 balance 6 square. 6 square is 36. 36 and 3 is 39. Right? If I have to find the square of say 81. 81 square. So 1 square is 1. 2 1s are 2 and 8 2s are 16. 16, 1 carried. 8 square is 64 and 1 is 65. My answer is 6561. If I have to find the square of say 90, not 90, say 74, right? Otherwise, through base method again you can solve it, no problem with that. But here, how do we apply it? 4 square is 16. 4 square is 16. We are left with 1. 2 into 4 8. 8 7s are 56 and 1 is 57. Now 5 is left. 7 square is 49. 49 and 4 is 49 and 5 is 54. So my answer becomes 5476. Right? So this is the duplex method. Through duplex method we can directly find the answer, and especially if we have some numbers, say bigger number, higher values, so we can reach out to that easily, right? Say I have to find the square of 142. I have to find the 142 square. Right? What I do? 2 square is 4. 2 to the 4 and 44 are 56. I'm left with 5. I'm left with 5, right? Now 14 square is 196. 196 and 5 is 201. So I got the answer to be 20164. So answer can be found very easily, pretty easily, right? Especially it depends on what are the number that we are using, right? And especially up to 5, till 5. If the larger is less than 5, then this method of this duplex method is very effective, right? So what we need to do is we need to practice a few more examples on this duplex method, and once that is done, the things will become very easy for you, for us, right? We can follow both the methods, base method as well as the duplex method. Both the methods are okay with it. As far as ending with 5 is concerned, that's an independent method, and I think that's the most effective one, especially for the numbers ending with the 5. Done, right? So what I would like you to do, if you're watching our video, right, you can take a pause over here and just go through all the concepts, right? I hope that you are carrying a pen and paper with you, right? And you just revise all those things. We have done 3-4 things, right? You can revise all those things so that the concept is completely clear and you can apply it during your questions, right? After this, next we go to our next approach, that is finding the cube root, finding the square root. We'll go to cube root later, but finding the square root. We go to this first, finding the square root, right? So normally we know that I told you that till 40 we need to know the squares, and if we know the squares we can find the square roots as well, right? But beyond that, if we have some bigger values, higher values, how we can find out the square roots? By just observing the digits, just analyzing the digits, and just directly taking out extracting the result out of that, extracting the answer out of the digits only, based upon the digits only, right? So let's before we go ahead, right, we need to analyze few basic things. First of all, let's work upon the squares, right? You have learned the squares, but I just want to write them again. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, 10 square is 100. Sorry. Now, here let's observe these. That's how the things work, right? Look here. Here in the end, that what we are getting, if you observe the digits here in the end, we are getting digits 1, right? And 1 also figures in the end of this 9 square, that's 81. So if in the end we get 1, right? Because these digits are going to repeat again, right? Look, if I go to 11 square, it is 121. If I go to 12 square, it is 144. If I go to 13 square, it is 169. If I go to 14 square, it is 196, right? If I go to 15 square, it is 225. If I go to 16 square, it is 256. If I go to 17 square, it is 289. If I go to 18 square, it is 324. If I go to 19 square, it is 361. And if I go to 20 square, it is going to be 400, right? Now, observe it properly, right? It's if in the end it is 1, it's 1, 4, 4, 9, 9, 6, 6, 5, 5, 6, 6, 9, 9, 4, 4, 1, and here is 1, is 0 and 0, right? So digits are repeating, and this 1 is because of this one, this 4 is because of this 2, this 4 is because of this 2, right? So based upon the last digit we get, we can predict the last digit of the number, right? Like that we have 1 over here. If we get 1, so then 1 must be coming. If we look at a number, right? Say we have one number, we want to find out the square root of that number, and in the end we are getting 1. So 1 must be coming from which? 1 must be coming from either from 1 or from 9. So last digit of the number must be 1 or 9. Then afterwards we are getting 4. So 4 we get from either from 2 or from 8, right? If we talk about say 9, 9 we get either from 3 square is 9, and or from 7. If we talk about 6, 6 we get either from 4 or from 6, right? And as far as 5 is concerned, 5 we get from 5, and 0 we get from 0, right? So here we can just focus on the 4 pairs. 9 1 is 10, 8 2 10, 3 7 10, 4 and 6 10, right? So what we can do is 1 2 3 4 5 6 7 8 9 10, right? So how they are paired? It's 1 and 9. This is 2 and 8. This is 3 and 7. This is 4 and 6. One number, this whenever there will be confusion, one digit will be less than 5, other digit will be more than 5. It's clear? 1 9, 2 8, 3 7, 4 and 6. Right? So we need to just have a focus on these pairs, right? So based upon this, we can find out the square root very easily. Now, what we do next? We take a one example. We take a one example of, say, we want to find out the square of 4096. We want to find the square root of 4096. Now, what we do? How do we approach? The first step is we focus at the unit place digit. Unit place digit is 6 over here. So what does it means? Last digit of the number will be 6 comes from 4 or 6. The last digit of the number will be either 4 or 6, because only 10 they can be 6. Otherwise there are no chances of having 6 over there, right? Now let's ignore these numbers. Let's ignore last two digits, because we are going to find out the square root. So let's go to the next. After ignoring the last two digits, we have already from 6 we have taken out 4 and 6. Now let's focus on the remaining digits. Remaining digits are 2, that is 40. Right? Now look at the table of the square. 40, this is 1, 4, 9, 16, 25, 36 and 40. So 40 figures out here. 40 appears here at this level, right? So it is after 36. So 36 is the square of 6, right? So what we can do that 40 is just after the square of 6. 6 square is 36, right? So after 36 there is 40. So the number is 64 or 66. So one thing is clear, that my answer is, my number over here is either it is 64 or it is 66. So in two steps, two simple steps, I can just reach out that these are the two numbers out of which one will be my answer, one will be the square root of 4096. Now, how do I approach? How can I approach to the next level, right? Next, what I do in the next part, right? Out of these two, I have to finalize that which is my answer. So between 64 and 66, there is one number, that is 65, right? That we know, because whenever there will be confusion, one number will be less than 5, other digit will be greater than 5, right? Now, if we have to find the square of 65, so it will be, I know that ending with 5, what we do? This is 6 and while we add 1 into this, 6 and 1, 7. So it is 7 6 are 42. 7 into 6, 42 and 5 square is 25. So 65 square is 4225. So the first two digits of 65 square is 4225. Now we are want to find out the square root of this. Here the first two digits are 40, right? And here in 65 the first two digits will come out to be 42. So in 65 the first two digits are 42, and if the first two digits are 40, that's less than 42, then obviously this number must be coming from a number less than 65. This 40 must be coming from a number which is less than 65, because 65 square is 4225. 66 square must be more than this. In 66 square, the number here, the digits here will be more than 42. In 64 square, the number will be less than 42, right? So here the number is 40 is less than 42. So my answer for this question will be 64. 40 will come in the, might be coming in the square of 64, right? So we can find this answer in 3 simple steps, right? We need to practice, we need to take up a few more examples, and once we do 3-4 examples, the concept will be we can easily clarify the concepts, we can easily follow the things, there won't be much of issue about it, right? So let's move on. There's one number that's 68, this number is 6889, and we need to find out the square root of this, right? Now first thing that we go to this number of 9. 9 comes from either from 3 and from 7. This is the first step. Then we go to 68. 68 comes after the square of 8 square is 64. 8 square is 64. After 64 it comes. So the number is either 83 or 87. Right? So my answer will be out of these two. Now in between them there is one number that is 85. Always we take the middle number that is ending with 5. So 5 square we all know that is equal to 25. 8 into 9, 8 9s are 72. So 68 is less than 72, because 85 square will be having 72 as the first two digits, right? So if the 87 square will be there, that will be having more than 72 value in the first two digits. So if the value is 68, which is less than 72, so it might be coming from a number less than 85, that is 83. So my answer for this question is 6889, right? I think that things can be done easily. That's hardly an issue, right? Hardly much of the issue. Let's go ahead. Let's take up one more examples. We take up example as 5041. We want to find the square root of this 5041, right? So here we have 1 as a value, right? Let's focus on the unit digits, 1. So 1 comes from 1 or 9. Then 50. 50 is after 7 square 49. So it is, the number is either 71 or number is 79. Then what next? Next is 75, right? 75 square we need to check. Now again, we don't need to focus on this 5 square 25. This we know that this will always be 25. What we are concerned with? 7. 7 into 8, that is 56. So this 50 is less than 56, right? So my answer will be smaller number, that is 71. My answer will be smaller number, that is 71, right? Okay, let's go to the next question. We can take up the one example, that's 4489. We go to this, is 4489, right? Now in this case 4489, we go to 9. 9 comes from either 3 or 7. Then 44. 44 is 7 square is 49, 6 square is 36. So it is 63 or 67. So in between we get a number that is 65, and 65 square, if I have to find out, the first two digits will be 6 into 7. 7 6 are 42 25. So 42 will come in the square of 65, and here we have 44. So 44 is a higher value. So it is a higher value, it might be coming from the bigger number, higher number. So answer comes out to be 67. Right? You can take up more examples. You can just use calculator, right? You can find, say, 10 values, 20 values, right? And then try to find out the square roots, right? And it will become very easy for you. If you practice, say, 10 to 15 questions, the concept will be very well clear to you people, right? Then next, I take up some examples, then some bigger examples. Say I have to find out the square of, say, square root of 8464. I have to find out the square root of 8464. So this 4 comes from 2 or 8. 84 is basically 92 square or 98 square. In between comes 95. 9 into 10 is 90. So 84 is less than 90, so answer is 92. Very simple and straightforward answer, right? If I have to, I have a answer this. I have a question. Square root of 13456. I need to find out the square root of this 13456. So 6 comes from what? 6 comes from 4 or 6, right? 4 or 6. Next, leave these last two. 132. So 134. Sorry, 134 comes after the square of 12 square is 144. 11 square is 121. So it is 114 or 116, right? So either of these two, I will be having some answer, right? Either 114 or 116. Now in between comes 115. 5 square is 25, and 11 into 12, that comes out to be 132. So 134 is greater than 132. So my answer will be the bigger number, higher number. 116. Sorry. So my answer comes out to be 116. I hope it's aptly clear to everybody, right? You can follow the things, right? And again, I'm telling you what you need to do is, right? If you want one question sure shot through squares in your competitive exams, what you need to do is you need to follow these things. You need to practice these things, right? So that once it is done, right? Once when you go for the calculation or simplification or some other question, you can directly apply these concepts, right? And if you don't apply these concepts on the regular basis, you won't be able to do it. Won't be able to replicate these things in actual exam, right? If you want to carry these things to the year exam, right, start practicing these things, right? Just work on these examples. They work on the more and more examples, right? And once you get used to these things will become the part of your normal calculation, right? And then you don't need to go back and recall these things, right? So only thing that is required is that you need to practice in the beginning, and when you go for the conceptual question or the practicing, right, you will be following the things automatically. Hardly an issue with it. Clear? Done? Right? So in this session, what we have done the squares, we have done the square roots, right? Then on the basis of square roots, few more things that I want to discuss, right? Sometimes we come across some very simple, straightforward questions, right? Like you might be have come across a question like 6 plus 6 plus 6 plus 6 plus so on up to infinity, right? Such questions are there, and there is square root. Then there is square root, right? Such questions are also being asked. You might have seen such questions, right? So how do we solve such questions? How do we solve? Because this is again part of square root only, right? How do we approach such questions? Normally what we do, they are infinite sixes, right? So what I do, I assume this value to be x. X is equal to this one, 6 plus 6 plus 6 plus so on up to infinity. So now, in this case, what I do that I assume that how many sixes are there, right? How many sixes? Infinite means what? Infinite means like that. How many drops do we have in a sea, in an ocean, right? How many drops, water drops? How many water droplets we have in the ocean, right? There are infinite droplets, right? So if I take one droplet, one drop from this ocean, does it change the ocean? No. So similarly, what I do, I take this 6 out of this whole number, whole value. So x is equal to the 6 plus, I take the square root of the 6 plus what, right? This whole is what this whole is left, right? If we cover up this one, right, what the whole remaining portion is left? This is again x. So it is 6 plus x. Now if we square these values, we get x square is equal to 6 plus x. X square minus x equal to 0. If we factorize it, so we get x minus 3 into x plus 2 as factors equal to 0. The value of x comes out to be 3 or minus 2, right? So this value cannot be negative, so we reject this one. My answer for this question will come out to be 3, right? So this is how we solve this question. There can be sometimes there can be negative signs as well. We might have some question like 12 minus 12 minus 12 minus 1 up to infinity. You might have seen such questions, right? And how do we solve these questions? How do we approach these questions, right? This is what we need to learn, right? Now, we assume we approach the question same way. We assume x is equal to this, and there are infinite 12. So like we have drops in the ocean, right? And we take out one drop from the ocean, and ocean remains ocean, right? Ocean remains same. So what do we do? X square is equal to 12 minus x. No, x square plus x minus 12 equal to 0. X plus 4 into x minus 3, these are the factors, equal to 0. X comes out to be minus 4 and x comes out to be 3, right? One value comes out to minus 4, other value comes out to be 3. As told you, this cannot be negative value, cannot be there. So my answer for this question will be 3. So this will come out to be 3, right? So this is how we approach, how this is how we can solve the questions, right? But apart from this, that when we are actually going for the competitive exams, so we need to learn that how these questions are being framed, right? And how we can answer these questions fast, right? Because ultimately, this whole competitive exams, right? All the competitive exams are based upon the speed only, right? You need to you need to speed up the things, right? And if you want to finish the paper in the given time, right, you need to work out the things in a fast manner, right, at a healthy pace, right? So what I want that you need to observe, you need to analyze each and every question, and then just try to figure out the simpler and simpler and simpler way, right? The best technique to solve a question. Fine. So here, to such questions that we can you find these questions, the answer to these questions in seconds, in the fraction of second, right? So before we move ahead, we need to know that I just want to introduce you something about our special series. Special series. What is this special series? See, look here. This special series is about, right? I'm just taking out some numbers: 2, 6, 12, 20, 30, 42, then 56, then 72, 90, 110, and so on, right? So this is special series, right? And now, what is special about this series? That we need to know. What is special about this series, right? Look, I just write down the natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on, right? Now, 1 into 2 is 2, 2 into 3 is 6, 3 into 4 is 12, 4 into 5 is 20, 5 into 6 is 30, 6 into 7 is 42, 7 to 8 is 56, 8 into 9 is 72, 9 to 10 is 90, 10 to 11 is 110, 11 into 12 is 132, right? So this is form where we get these special numbers. This is form where we get the special values 2, 6, 12, 20, 30, 42, 56, right? Now, when we get a question like 6 plus 6 plus 6 plus 6, that's on up to infinity, right? So how do we approach this? You got it? It's how we are getting this special series, right? Then we have another root, and then we have another root, right? Now, if I have to find out the solution for this is, right, I need to know the form where the 6 is coming. 6 is coming from form, it is 2 into 3. 6 is coming from where? It is coming from 2 into 3. 6 is 2 into 3. Now, next thing, what we observe, what is the sign over there? This plus sign, positive sign. So, if it is plus sign, this value will be 3, value will be higher, right? Had it been instead of plus, had it been minus, negative sign, then the answer would have been 2. Answer would have been lesser value, right? If you go back, here we have this question, 12 minus 12 minus 12. So what we do, this 12 is 3 into 4, right? 12 is 3 into 4, right? And 12 is coming from 3 into 4. So here the sign is negative, so my answer is clearly 3. I don't need to carry out all this. This is not required. This is not required at all. We can just have a look at the numbers and actually find the answer for this, right? If I have say, I have a question, it's 42 plus 42 plus 42 plus 42 and so on up to infinity, right? If the numbers are moving this way, right, then what we need to do is so on up to infinity, right? So in this case, what we need to do is we need to just find out the square root, then we find out the square root, then we find out the square root, right? Now here the sign is plus, the 42 is 6 into 7, sign is plus, answer is 7, right? So we don't need to do anything, we don't need to make any extra effort. Directly we write down the answer. Just we need to have a clear idea that this concept is applicable only in case of special series, and 95% chances are there whenever you have a such question till infinity, you will have a number from the special series, because if the number is not from special series, normally it cannot be solved. Normally it cannot give you a rational solution. Normally it cannot give you a integral value. So now, whenever a paper setter is setting up a question, right, he has a very clear idea in his mind, right? He doesn't want to complicate the things, right? So otherwise the answer will come into the roots, right? Say root 13 plus 4 upon 2 root 2, right? Something like that, right? So he doesn't want to complicate the things. So in order to keep the things simple, right, he will give you the values out of the these special numbers only. And when the value is from special numbers, means question is a number kitty, right? So 1 second questions, right? And we find normally 1 or 2 questions like this, 1 or 2 questions, a few of the questions which we can solve in 1 or 2 seconds. And this question, this type is from that category, right? Clear? But this question will be asked normally mostly in the state level exams or the banking exams, especially the bank clerk exams. Fine? Okay. So we have done the addition sums, we have done the subtraction sums, right? Next we have the multiplication sums, right? There might be the case like you're asked that x is equal to 7 7, 7, and so on up to infinity. There might be a case, and there is no sign between them. When there is no sign, it means there is sign of multiplication, right? X is equal to so on up to infinity. Now, what we do, we follow the same method. Otherwise, the answer for this question is, we can simply write the 7. If the value is 7, the answer is 7. If value is 8, the answer is 8. If value is 9, answer is 9. So special series is not required over here, right? And how do we get this answer? We square this. We assume this x is equal to 7 plus the, how many drops are there in the ocean? There are infinite drops, and we take one drop out of it. Plus 7 is taken here, and rest what we are left with? We are left with x root. So x square is equal to 7x, and we take x square minus 7x equal to 0. We take x common, x minus 7 equal to 0. So x is equal to 0 or x is equal to 7, right? So here 0 cannot be the answer, so my answer is 7, because it's very clear, it's not 0, right? So my answer is 7 in this case, right? So my answer comes out to be 7. Clear? Very easy question, right? And we can find the answer pretty easily, hardly an issue with it. Clear? Done? Done with the things? Okay, fine. So after this, we go to next. As far as the squares and square root is concerned, we have done most of the things, right? And next, afterwards, we go to the concept of cube root. Right? There is one method for solving the cubes, but I'm not going to focus much into this, right? I just want to keep the thing simple, and because there in finding the cubes, right, hardly any question is being asked, right? And even if it is being, you can find some question, right? Then if you follow the method, because very rarely you will be using this method, and then it is not going to help you much, because we can use only those methods which we are from where we can expect some questions, right? Frequent questions, right? If we focus on some method, and we can find that question coming up very rarely in the exam, right? So in that case, even if the question figures there in exam, we won't be able to replicate the method or the concept, right? So we will be following only those things which we can follow continuously, right? Which we can practice continuously, which we can recall, remember, right? So there are a lot of things which are one-time things, and recall value is very low. So I don't want you people to focus on this, right? So let's come to the next thing, next question, right? Cube roots, finding the cube roots. So in cube roots, we normally we come across a question like, we have a number 175616, right? And we have to find the cube root of this number, right? So this is a very problematic question, right? Because what happens normally in the lower classes, when we used to solve these questions, how we have solved it? We used to factorize it. We used to divide it by 2, then 3, then 5, then 7, then 11, 13, 17, 19, till we get all the factors, and then those factors are written in a line, and then out of that, the triplets are made, that out of every 3 we used to take out 1, next 3 we used to take out 1, and then multiply the those values, and we used to get the cube root. But in actual exam, right, as we have seen that we hardly have say 30 to 35 seconds to solve one question in mathematics, in the math section, right? So we cannot think of going to that approach and just factorizing the 175616, right? We won't be able to factorize in an entire 1 minute, right? So what we need to follow the alternate methods. We need to follow the shortcuts where we can write down the answers in seconds, in 1 or 2 seconds, right? So what we do over here, let's try to find out the cube roots, right? So before we go ahead, we need to learn, like in squares, we need to know the basics of the cubes, right? I told you we need to know the cubes till, 20, right? So to find out the cube root, right, we need to know cubes at least till 10. I'm just writing it down. Cube of 1 cube is 1, 2 cube is 8, cube of 3 is 27, cube of 4 is 64, cube of 5 is 125, cube of 6 is 216, cube of 7 is 343, 8 cube is 512, 9 cube is 729, and 10 cube is 1000, right? Now afterwards, after this, right, if I have to, if we repeat the cube, like if I have to find the cube of 11, that will be 1331, right? Similarly, if I go to cube of 12, 1728, right? So similarly, just 1 is repeating, 8 is repeating, similarly all the values will be repeating again, right? So what we learn over here, right? Here we just like in we did in the square roots, similarly here in cube roots as well, right? What where we focus at, we focus at the unit digit, right? Here the unit digit is 1, right? So what I do, right, let's try to see this. 1 comes from where? This 1 comes from 1, right? Then this 4 comes from 4. This next number is after 4, after 4 there's one number, that is 125. In 125, this 5 comes from where? 5 comes from, this 5 comes from this 5. This 6 comes from 6, right? This 9 comes from 9, and this 0 comes from 0, right? So all these numbers comes from themselves, right? This 5, this 5, 6, 9 and 0, right? So when we get 1 in the end, it might be coming from, it must be coming from 1. If we are getting 4 in the end, it must be coming from 4. If we are getting 5 in the end, it must be coming from 5. If I getting 6 in the end, it must be coming from 6. If I get 9 in the end, it must be coming from 9, right? So apart from this, if I get 8 in the end, so 8 in the end will come from 2, and 2 in the end, look here, 2 in the end will come from 8, right? 8 comes from 2 and 2 comes from 8. Similarly, if you look at 7 comes from 3. 3 cube is 27, 7 comes from 3, and this 3 comes from 7. Vice versa. 8 comes from 2, 2 from 8, 7 comes from 3, 3 comes from 7, right? This is the only thing we need to remember. 8 to 10, 7, 3, 10. Apart from this, we don't need to remember anything else, because for the other values, we know they are coming from themselves. They are coming from their own values. They are coming from the their own, right? If 1 is coming from 1. 4 from 4, 5 from 5, 6 from 6, 9 from 9, right? So now, if we are going to solve the question, right, we look here, right? Here, this 6 must be coming from 6, right? Then we ignore the last 3 digits. If we are finding the cube root, we need to ignore the last 3 digits, right? Write down the unit digit from here, right, and then ignore the rest of the 2 digits, right? So as we did in finding the square roots, we focused upon the unit digit and ignored another digit. We ignored the last 2 digits, right? Fine. So in cube root, we ignore the last 3 digits. Now, next is 175. So 175, if we look at in the table of cube, 175 fits in here. 175 fits in here. Yes, after 5 cube is 125. After 5 cube, 175 will be somewhere here. After 125. So it is 5. So 175 comes after 125. So my value will be 5. So my answer will be 56. You can use it, you can calculate it from the calculator, and you can find the answer, right? I'm just going to give you one more quick value. Yes, the number is it has 474552. We need to find out the cube root of this, right? So here in this case, what we can find out, here in the end the value is 2. So this 2 comes from, we have seen the 2 comes from 8. 2 comes from 8. So we can ignore the last 3 digits. Rest we are left with 474. So 474, if we look at it, is after 343, it is right 474 is after 343, so it comes from 7. So answer is 78. I can easily find out the answer, right? I hope that it's clear, right? I can take up a few more examples, like there's the answer is 85. Question is 85184. 184. I need to find out the cube root of this number, right? So here, this 4 must be coming from 4, right? Ignore the last two digits, last three digits, 85. If we take 85, 85 comes after 64. So my answer will be, 64 comes from 4. So my answer will be 44, right? Then let's go to another example. The number is 250047, and I need to find out the cube root of this number. So here it is 7. 7 comes from 3, right? Ignore last three digits. 250. 250 is after 250 is here after 6. So my answer is 63. Right? Easy. It's very easy concept, right? You can solve the question in fraction of seconds. In 1 or 2 seconds, you can get the answer, right? Say, I'm taking one more example. It's 7553 571. It's 571, right? I need to find out the cube root of this, right? So what we get is, in the end we have 1. So 1 comes from 1. This 1 comes from 1, right? Ignore the last 3. 753. 753 comes after 729. So my answer is 91. My answer is 91. Easy, right? If I have a number like this number is value is you can get it 681 and 472, right? You have to find the cube root of this. So what we do here, in last 2 comes from 8. Last 2 comes from 8. Ignore the last 3. 681. 681 you can find out after 512, that is 8. So my answer for this question will be 88. So you can find the answers to these values in 1 or 2 seconds only, right? It's very easy to follow. This concept is very easy to follow, right? Practice a few more examples, 8 to 10 examples, right? And this 1 mark is sure shot for you in the exam, right? There are 2 types of questions that are being asked based on the cube roots, right? One is this one, where we have to find the perfect cube root, right? And second is the approximation part. So in the approximation part, we'll find some question where not the exact value but approximate value will be given. So that we will be covering up when we follow this concept of approximation. That is going to be during the part of this approximation, and after approximation, during the simplification part, we'll follow this approximation session, right? But till now, in the cube roots, you need to remember this concept only, right? So again, I hope that this session will add some value to your armory, right? And you will be better prepared for your competitive exams, right? And it's time that you start working on the basics. Again, I would like to remind you one thing, that go back and go to the tables, right? Learn those tables. Religion is very important. It's unless and until you are done with the tables, right? Your speed will not improve. You have to work on continuous work, right? You remember that when you were in the 5th class, right? You were having the clear idea about the tables. You used to learn the tables daily basis, right? So, and we were going to that, right? I think that we carried those things till 9th or 10th class. But after 10th, we normally stop using the tables, right? And we moved on to the calculators and all, right? But now it's time that we go back, because in the computer exams, we don't get the calculator, right? So, and even if in some exams, even if we get the calculators, right? There are also, calculator is slower than our mind, right? Our brain is faster than calculator. So, there are a lot of things where your brain can help you in a faster way. right? So what I would suggest that you start working on the scratch, work on the tables, work on the squares, work on the cubes, right? These are the basics, right? And I'm telling you one thing, that if you follow all these sessions, you will never ever find any problem, especially in the simplification part, right? And we will take you gradually through the whole of the mathematics, right? We are starting from the basics, we are starting from the scratch, right? And if you follow all the lectures in the sequence, right, you will not be having any problem in any exam in the mathematics section, right? So see you soon in the next video, right? Till then, all the best, right? Enjoy your time, right? And if you want the notification of for the next video, subscribe the channel and subscribe the, and you can also share it with other your friends and other thing, right? So that the more we can reach out to the more and more people, right? So thank you very much. That's it from my side. Thank you.